Hi, today we're going to talk about the second type of motion graphs, velocity or speed versus time graphs. Well, the first thing is remember when we're talking about velocity or speed versus time, what we're referring to is that time will be on the x-axis or velocity or speed will be in the y-axis. And what's the main difference between velocity or speed? Remember that velocity was the vector, and speed was the scalar. Okay, so in our graphs, the main difference is that if we have a velocity versus time graph, we can have this sort of graphs where we have negative velocity, which means that the velocity is going in the opposite direction. Because remember that vectors have a direction. Whereas if we're having speed versus time graphs, we are never going to have anything in the negative part of the y-axis. Okay, so once we've established that, what are the main things that we have to see in both velocity and speed versus time graphs? Okay, so remember that we have time here and we have velocity. I'll keep with the velocity because it can be speed. Okay, and basically we're going to have three types of shapes. 1, 2, 3, 4 types of shapes. Okay, so we can have a straight line going up, a horizontal line, a straight line going down, okay, or we could have curves both going up and going down. Okay, so we're going to look at these sections and see what each one represents. Okay, so remember that in that the acceleration was final velocity minus initial velocity divided by the change in time. So change in velocity versus change in time. If we think that the v is the y in the axis and t is the x, okay, so then we're talking about change in y versus change in x, which is a slope. So basically, the acceleration is the slope of a velocity versus time or speed versus time graph. Okay, so a straight line both going up or going down. A straight line going up means a constant acceleration. Because the slope is always the same in this area. Okay, a straight line going down means constant deceleration, constant deceleration. Okay, so it means it's the velocity is decreasing at a constant speed. Okay, at a constant rate. Sorry. Okay, a horizontal line means the velocity hasn't changed in that time, so it means constant velocity or constant speed, uniform velocity. Okay, and so now we get to the curves. What does the curve mean? Well, a curve going up means increasing acceleration, not constant. And a curve going down means decreasing acceleration. Means that it's non-constant deceleration. When acceleration is not constant, it might be a bit difficult to differentiate between one graph and the other. For example, when acceleration is constant, you can easily see that this is accelerating and this is decelerating or slowing down. Okay, but when the acceleration is not constant, we have 4 other types of graphs, as you can see. Okay, so this is accelerating, but it is increasing acceleration. Why? Because the slope is increasing gradually, and that's the way you can see it. Just try to draw the slope at each point, and you'll see that the slope will be increasing. Okay, so it is accelerating, but it's increasing acceleration. Okay, and this is accelerating too, because the final velocity, when it's accelerating, the final velocity is greater than the initial velocity. Okay, this is accelerating too, because the final velocity is going to be greater than the initial velocity, but it is decreasing acceleration. Why? Again, because if we take a look at the slope, the slope is getting smaller and smaller each time. Okay, we can take a look at the deceleration. Both of these are deceleration. Why? Again, the way to differentiate it is because final velocity is smaller than initial velocity. It ends up in a smaller or lower velocity. Okay, but as you can see here, take a look at the slope. It starts nearly horizontal and then it starts to increase. So this is increasing with increasing acceleration or deceleration. Okay, and if you see here, it's got a high slope and then it goes nearly horizontal. Okay, so that's decreasing acceleration. Okay, so that's half of what we have to look at. What's the other thing that we have to look at this sort of graphs? Well, we have to understand that in a so what we have to see now is that if we have a velocity or speed versus time graph, the area under the graph is going to be the distance traveled. And this is very easy to see if we think of the, so if this is very easy to see if we think of the equations of motion. The second equation of motion was this. Okay, so let's consider that we start at the origin, so that's 0, the equation, and in the case where we have no acceleration. Okay, so then we have a constant movement with this equation. And if we see this, that area of constant was the horizontal line, and if we look at the graph, this area, this section over here is going to be t, and that section over there is going to be u. So if we multiply u by t, we get that area. Okay, so any area that is horizontal, that is with no acceleration, is going to be the area of a rectangle or a square. Okay, so and what is the section with what happens when we have acceleration? Okay, then we can consider that if we have no initial velocity, we can consider that that is that. But if we think that the acceleration is velocity divided by time, and so that is that, we can substitute that equation like this. And that is the area of a triangle where we have t as the base and v as the height. Okay, so in order to calculate the distance traveled, we have to calculate the area under the graph. If we have something like this, like the example we saw before, it is very easy because we just have to divide this into 3 sections, and that's going to be the area of 2 triangles, 1 and 2, and a rectangle. Okay, if we have, we can have another case where we start with an initial velocity, for example something like this, And we have two options there for to calculate this area over here. Okay, we can divide that area into a triangle and a square and calculate it separately, or we can remember that the area of a trapezium was half the big base plus the small base times the height, and we can consider that this is the small base, this is the big base, and this is the height. Okay, so we can calculate the whole area as the area of a trapezium, or we can calculate it as a triangle and a square, and the rest are all calculated the same. Okay, so as a conclusion, velocity versus time graphs, we can have speed versus time graphs. In velocity versus time, we can have negative velocities. In the speed, we don't. And we have various options. One of them is a straight line going up. That's constant acceleration. We can have a straight horizontal line. That's constant velocity. We can have a straight line going down. That is a constant deceleration. And any curve will be non-constant acceleration, because the acceleration is going to be the slope of our graph. And so we have to divide it into sections. And the distance is going to be the area under the graph. So I hope this helps.